Good morning, everyone, and welcome to Bussmann University, a series of webcasts where experts from the Bussmann Series team cover today's most pressing overcurrent protection topics. My name is Shannon Stokes. I'll be your moderator for today's webcast. Today's webcast focuses on UL low voltage fuses, and our speaker is Matt Sukley, a field application engineer for Bussmann Series Solutions. Matt provides technical guidance to consulting engineers, OEMs, electrical contractors, and industrial and electrical inspectors. Throughout this webcast, you're welcome to submit questions through the Q&A chat window. We'll do our best to answer them before the end of this call. In the next day or so, you'll receive an email with a link to watch this webcast and our previous webcast on demand. Be sure to check out our upcoming webcasts as well. With that, I will turn it over to Matt. Matt?
Thank you, Shannon. I appreciate the introduction. Just once again, my name is Matt Sukley. I'm a field application with Eaton, specifically for the Bussmann division. I've been on board with Bussmann for about 13 years now. And what we're going to do today is go over an agenda that highlights UL low voltage fuses, the types, the applications, how to apply them, different types, different classes. And when we look at the agenda for today, we'll see that it says we have types and classes of fuses. We have branch circuit fuses. We'll go over definitions of a branch rated fuse. We'll go over the UL classes. What makes up a UL class? What do they say? How do we build? How do we make a UL class of fuse? We'll also go over supplemental fuses. What are supplemental protective devices? Where can they be applied? What types does Bussmann offer? What types of fuses are available for those applications? And then after that, we'll talk about choosing the right fuse for the job. So we're going to go kind of class by class, supplemental fuse by supplemental fuse, and make sure that, hey, we're going to choose the right device for the application to make sure that we protect what you have in the field. And then finally, we're going to go through some accessories that are out there. Where do we apply these fuses? How do we use them? What do we put them in? Are there special considerations for different types of accessories that we have? Is there something out there that maybe you never thought of that we could help you design and help you with your system? So when we look at the different things within Bussmann and the different fuses and electrical characteristics, these characteristics are out in the marketplace now, and you may see these, all over the place. When I go out, when I started Bussmann, there's a lot to take in. You hear about non-time delay. You hear about fast acting. You hear about time delay. Sometimes people call these slow blow. You'll hear about single element fuses, dual element with time delay. Current limiting as well is a big characteristic within a lot of fuses. And then finally, there's something out there called high-speed fuses. So that we're not going to get in too much into high speed, but I will mention it one portion of this presentation. So my plan today is to kind of go through all these characteristics and where they are in every fuse class that we have, as well as the supplemental fuses that are out there. But I'm not sure how many people participated in our presentation 2 weeks ago. So I'm going to go over through a basis of design of a fuse and what's actually in some of our fuses first. So when we look at the next fuse and another type of fuse that we have, our single element fuse, which is the first one on that list. So when we look at this fuse, it's a very straightforward fuse. So what's in there in a single element fuse is exactly what we say. It's one element that goes through this fuse. It's designed, different alloys are in there, different metals are in there, depending on what type of characteristics we're trying to get out of this fuse. So in this particular case, under sustained overload, a restricted segment arcs and melts. So we have an overload condition. This fuse will actually start opening up, and depends on how big the overload is, how quickly it will start to arc and how quickly it will start to melt. When we look at a true fault condition that may go through this fuse, now all of a sudden you're going to get multiple restricted segments that start to melt simultaneously. So what happens is now we have maybe a more violent condition when we have a fault current that goes through there that's much larger than what the fuse that it's rated for. And when I say rating, if it's 100 amp fuse, now we see 1,000 amps through there, or 2,000 or 5,000 amps go through there. This fuse is going to open up very quickly, and it's going to melt those segments back to the point now. What happens is a gap is formed in those legs, and that gap and the arc is extinguished by an arc quenching filler material, which is a silica sand type filler. But inside this fuse, we pack this fuse full of a silica sand filter that what will happen is when that arc develops, it starts chewing back those links. All of a sudden, that arc will get quenched by the silica sand filler, and we'll actually then quench it and then open up the circuit to make sure no more current can go through. So that's kind of a simple application of a single element fuse. When we look at a dual element fuse, which has been around for a long time as well, so we look at this particular fuse. The nice thing is with a dual element fuse, we have two separate elements inside this, and both elements work very well for a specific application. So in this particular case, we have a short circuit element and we have an overload element. When you have a single element fuse, you have one element in there and it has to do both jobs, right? It has to do the overload and the short circuit. Well, now we go to dual element, we can compartmentalize this a little bit. So now we have a short circuit element on the left and we have an overload element on the right. So it's a true dual element design, and depending on what kind of fault we get through this fuse, that's the element that's going to pick up the fault. So if you look at what happens when you have an overload operation, you'll have the overload element on the right-hand side that's held together by a trigger with a spring and a fusing alloy. So when it starts to see too much current flow through, so it gets too much of an overload condition. Maybe you have a motor that's out there that is just overloaded. Maybe there's too many rocks in the conveyor belt or something like that, and all of a sudden this fuse has to act in an overload type application. Eventually that fusing alloy fractures, pulls the spring from the overload element away from the short circuit element, and opens up the fuse. So in this particular case, we've got a reasonably mild condition, meaning it's not a short circuit, it's an overload condition. The current's in a normal path. It's just too much current that's flowing through this particular fuse, and we're going to open up under an overload condition. When we move on and we look at the next type of operation in a dual element fuse, we've got the short circuit element. Pretty straightforward. It's on the left-hand side. So when the fault current is that large that it sees it through and operates under a short circuit condition, they'll start to vaporize those neck down regions of that short circuit element. So as it opens up and as those things start to arc, they will open up. And similar to that single element fuse, now all of a sudden we're going to create that gap, and that arc quenching material that's inside there is going to extinguish the arc, forming fulgurite while forcing the current to zero. So if you ever heard of fulgurite, it's the same thing that when lightning hits the ground and forms like a glacial substance out in the desert. That's pretty much what's going on inside of here. So what happens is this arcing is so hot that it actually takes that silica sand filler and makes it into like a glacial substance that will quench the arc and then open up the circuit, and it does it very, very, very quickly. So that's the general operation of a dual element fuse. So if we look at the overall construction of the fuse and what goes into the fuse, there's more to it than just what's inside. Obviously, we've got the tube and the cartridge, and inside that cartridge we have our links. We have the fuse links, and we have the overload and the short circuit link, and then also we have the filler material that goes inside there as well. So we do have end blades on here that will then obviously make contact with your fuse block or your switch, whatever you're mounting this inside of. So when we look at what's also included in there, we have a physical rejection. The nice thing with a fuse is it's very difficult to put the wrong fuse in the wrong application. We'll go through that as the day goes, as this presentation goes on. But generally, as a UL fuse, we're going to make sure that we can only put the right fuse in for the job. So when we look at this, when we look at the physical rejection, it prevents the wrong fuse with different performance from being installed. It's enclosed and fixed thermal design. When we look at how a fuse operates, it operates on a heat. When it gets too much energy and it creates too much heat, it's going to melt away. And it's an enclosed, non-venting design. So the nice thing is arcing is contained inside the fuse body, leading to a safer electrical system. So you're not going to see any kind of venting, any kind of smoke, anything like that. In general, when a fuse opens up, there's no clickety-clack, there's nothing goes on, it just all of a sudden opens up and you realize, oh, there's no more current flowing to my system. We check the circuit, we go check the fuse, we check for continuity. And you always want to check for continuity across the blades themselves after the power shut off, and pull the fuse out and make sure you check for it, and then see if the fuse is blown. It is also a factory calibrated device, so there's no need for adjustments or field settings. If you do have a fault, we want to pull that fuse out, make sure you find out what happened, because one thing we'll let you know is under OSHA, you can't just go out and reset this thing or throw in a new fuse. One thing I don't like on the Bussmann side is, a guy will say, hey, I put in the fuse and it blew, and although that's maybe great for business, it's not good practice, right? We don't want to do that. We want to make sure that you clear the fault. Per OSHA, you want to go out and find out what caused the fault, and you want to go make sure you clear that fault and then put a new fuse in and make sure you're off and running and you have a safe situation. All right. So another electrical characteristic that's within a fuse is the current limiting nature of a fuse, so of particular fuses. So when we look at a current limiting fuse, what is it? So under UL 241-1 definition, a fuse that within a specified overcurrent range limits the clearing time at a rated voltage to an interval equal to or less than the first major or symmetrical current loop duration, and limits the peak current to a value less than the available peak current. So what does that mean? We're going to limit, when we have a current limitation, we're going to limit the fault current going through that to some value less than the peak that is available. So in this particular case here on the right-hand side, we'll see that we have 115,000 amps available. And depending on the fuse type that we put in there, whether it's an RK5, an RK1, a Class J, we're going to have a current limiting device in there. We're going to limit how much peak current gets through that system, as well as the I squared T that gets through there as well. So it's very important to understand that every class of fuse does not act exactly the same way. Class J is a very, very, very good current limiting fuse, best in class for current limitation. Then we've got RK1, which is still better than the RK5, and the RK5 has very good current limitation, but not as good as the RK1 and Class J. So the nice thing is that when you have current limiting fuses under UL 248, there's also a physical rejection of larger fuse amp ratings and for non-current limiting fuse. So it's very difficult to make a mistake if you have a fuse class and it's designed on a certain fuse class to put in the wrong fuse. All right, so if you continue looking at current limitation, once again, when you look at the normal load current that's flowing through, you'll see that it's a very low, and all of a sudden now, geez, I get a fault, I'm going to all of a sudden have a lot of fault current for one cycle or longer. That goes through with no current limitation. So when we're talking, why is current limitation important? It's very important to protect the components that are downstream of your device, and it's obviously important to protect the people as well in your building. So the nice thing is, we use a lot of current limiting device when we help with arc flash protection. We use it a lot when we're talking about component protection. So when we look at the next slide, you'll see that now all of a sudden, geez, we put in a current limiting device, so instead of allowing this fault current to flow through for that entire cycle or longer, we're going to see the fault, we're going to clear the fault, we're going to do it very, very, very quickly, within a half a cycle for sure. So it's a very good device. So what does that mean to you, and what does it mean to the world out there in the fuse world? Well, when we look at what a current limiting fuse is, UL defines current limiting classes of fuses. So we've got a Class J, we've got a Class CF, Class CC, L, R, T, and G. All right, so when we're looking at these classes of fuses, UL says, you know what, we're going to have a maximum let-through limit during fault conditions. So depending on which which fuse you have, we're going to limit how much gets through there. All right, we're also going to have a minimum voltage rating. We're also going to have minimum interrupting ratings for that. So whether it's 200,000 amps, 100,000 amps, or 300,000 amps, we're going to show what those are. So UL designates that. So in these cases here, we're going to have 200,000 amps for Class J, CF, T, R, CC, and L. We're going to have physical rejection of larger fuse amperages. So we're going to make sure that we can't put in anything larger than what it's designed for. And we're going to have physical rejection of non-current limiting fuses. So if you look at our two fuses there in the bottom right, you'll see that I have two fuses there. One is our basic design fuse, which is our NOS series, and we've got our low peak series of products. And you'll see at the bottom there's a little notch at the bottom of that fuse, and that's a rejection feature. So the main thing I want to make sure you're aware of on this call today is that when we talk about rejection fuses, and I may say this several times during this presentation, it's not the fuse that rejects something. It's actually the holder in the system rejects it. So what happens is if I have a fuse that is designed for that yellow fuse, for that rejection type fuse, I won't be able to put in the basic fuse on the right. That fuse holder, the disconnect switch, will have a little device in there that will allow that rejection feature to slide around. But if I go put an older class of fuse or a basic type fuse, it's not going to be able to fit, and the holder and the switch are going to reject that fuse. So even though it's a terminology, you say it's a rejection feature on a newer fuse, it's the actual holder and the system that's been designed that's going to reject it. So the nice thing is it's very, very easy to make sure that we put in the right fuse for the job. All right. So if we look at branch circuit overcurrent protected devices, what are they and when do we use them? So we look at an overcurrent device. It's a device capable of providing protection for service, feeder, and branch circuits and equipment over the full range of overcurrents between its rated current and its interrupting rating. Such devices are provided with interrupting ratings appropriate for the intended use. but no less than 5,000 amps. So the bottom line is when we have a branch-rated fuse, this fuse can be used anywhere in the power distribution system. However, there is a minimum 5,000 amp rating that we must meet. In most cases, our fuses certainly handle at least 5,000 amps and require to interrupt overloads and faults up to its interrupting rating. So that's the definition of a branch-rated device. And when we fall under a UL 248, we're going to see a lot of those fuses in here that are branch-rated devices. All right. So when we look at branch current over current protected devices by NEC standards, there are certain sizes that they consider the standard amp ratings for fuses and for circuit breakers. So if you look at fuses and fixed trip circuit breakers, the standard trip ratings for fuses and those breakers shall be considered as shown in the table below. So if we look at table 240.6, there's a bunch of standard ratings in there from 15 amps all the way up to 6,000 amps. But in addition to that, there are standard sizes or additional sizes that we can do in the fuse world that are different than what you see there. We have 1 amp, 3 amp, 6 amp, 10 amp, 601 amp, but there's also other sizes as well. When we start looking at our class CC and some other fuses, we can have different size fuses that are not shown on the standard amp rating, and it's perfectly fine. You'll see there the last sentence says the use of fuses and inverse time circuit breakers with non-standard ampere ratings shall be permitted. So we can do that in those cases. So when you look in the fuse world, if you look at a class CC fuse, you'll see a 7.5 amp. You'll see some other amp ratings in there. So don't be alarmed. They can certainly be used as branch-rated devices. So what is a branch-rated fuse? So under UL 248, there are certain guidelines, and not necessarily on all of them for sure. But just to give you a general idea of what we're looking at when we're designing a fuse and what you want to look at when you're looking at your fuse, quite frankly. So under UL 248, we'll say, all right, we need to know what the voltage is, what it's capable of handling, the physical size, what are the characteristics, what's the interrupting rating, is it a current limiting fuse, and obviously, what are those amperage ratings and ranges. So those are some of the things that are guided under UL 248. So when we look at what they are and how we adhere to those rules, when we go to the next slide, we'll see that a fuse is a fuse, right? No, not necessarily. We have a lot of different types of fuses and classes that are out there, and that's why we're in this training today, to kind of shed some light on what those are and how we can help you pick the right fuse for your job. So if we look at this page, you'll see a bunch of different types and styles of fuses. We've got Class CC, Class G, Class J, Class K5 and H, RK1, T, RK5, L, and some other fuse types, including supplemental fuses, as well as some cable limiters that are on this page. And we're going to kind of go through these, class by class, just to kind of let you know where they're used, how to use them. Is there any pitfalls, or is there any issues, is there advantages to one over the other? That's why we're here today. So hopefully we can straighten some of those questions out. So we look at a Class CC, and once again, this is governed by UL, right? So they're going to say under UL 248, if you're going to make a Class CC fuse, there's certain criteria that we have to meet. So when we look at this fuse, just to give you a general idea, this fuse is a 600 volt rated fuse. It's got very good current limiting to it. It's a 200,000 amp rated fuse. It's hard to tell on your screen, but this fuse is only 1.5 inches long, right? So it's a very short fuse. It's only maybe 0.4 inches in diameter, so it's a very, very tiny fuse. And this fuse can safely interrupt 200,000 amps, which is pretty incredible. So when you look at this, though, once we meet those criteria from UL, we meet the physical size, we meet the 200,000 amp rating, the voltage requirements, we can tweak this fuse to design it basically for our customers and for the branch. So in this particular case, we have an LPCC, which is a low peak time delay fuse. This is a very good fuse. Our low peak series of products is kind of the best in class. So whenever you see that terminology in LP in our part number, a low peak series or yellow series of fuses, it's our kind of a best in class for that series of fuse. So when we tweak it, this is a very good fuse. It has good current limit. It's a very, very good current limitation. It has good time delay, and it's a very, very good fuse. When we look at our FNQR fuse, this is our fuse that we're going to put in front of the transformer protection. So this has time delay, and it has a little more time delay than our LPCC. So in this particular case, when you have a fuse this small, it's very difficult to put a lot of time delay into these fuses. So with the FNQR, we pack in about as much as we can. It's very important when you're talking about transformer protection because when I put this in front of a control transformer, there's going to be an inrush to that control transformer. So I want to make sure that I put a very good time delay fuse in front of that control transformer or any transformer and make sure that that fuse does not prematurely open up. So that last fuse on it, a KTKR, is our Limitron. It's our fast-acting fuse. So this fuse here is very good for resistive loads and any load that does not have any kind of inrush to it. So when we're talking a fast-acting fuse, basically what we're doing is we're taking away the overload portion of that fuse. So it does not do a very good job of absorbing those mild overloads that occur when you first start up the transformer or a motor. So what will happen in that case, that KTKR fuse, quite frankly, would open up prematurely. You would see that inrush from that transformer open up. You call me or another application engineer, and we kind of let you know, hey, you got to put a time delay fuse in there, and we go to the FNQR. So FNQR is very good in front of transformer protection. LPCC is good all around for motor protection and for heating loads, resistant loads, everything. But just know that in general, if you're talking control transformers, we're really going to put that FNQR in there. So why do you choose a Class CC? For sure, it's the smallest branch circuit protection footprint. It's very current limiting fuse. It's got a very strong level of component protection. And then we could upgrade from some of our supplemental fuses as well to go to a Class CC fuse. When we're looking at some of the applications that we have, we've got motor control centers. A lot of times we'll put these in front of the branch protection for the motors themselves. We'll also put them in motor control centers for obviously in front of the control transformers that are in there. But we also have branch circuit protection and electrical distribution and OEM equipment, industrial control panels and machinery, and closed combination starters, and obviously control power transformer protection that we had talked about. So the nice thing is with Class CC, there are a lot of options as well. We'll kind of go over these later on when we have time. But there's a lot of different holders and things out there. For instance, those modular holders on the bottom left, they're kind of flip open type holders where you put the fuse in. It's a finger touch safe system. You close the door, and then it protects, this way it's all finger touch safe. You're not going to be able to get your fingers in there and get electrocuted very easily. So we just want to make sure that, we probably have, probably four different holders for these devices. So just know it's a nice option with options to have different holders as well. So we look at the next type of fuse. This is a Class G fuse. So it's not as common as a Class CC for sure, but the nice thing is with this fuse, it's a half amp up to 60 amp. It's a 100,000 amp interrupting rating. So it's a very small fuse. This is kind of a peculiar fuse as well because when we look back at the Class CC, they are all physically the same size. They're all going to be roughly the 0.4 by 1.5 inches. When we talk about Class G, we now have 4 different sizes from the half amp up to the 60 amp. And this is all designated by UL as well. But they're a little bit different than the standard Class CC. So in this particular case, you'll see on our screen that, at 600 volts, we have a half amp to 20 amp, but then at 480 volts, we only get for 25 to 60 amp. And then we have some DC ratings as well. So the nice thing is with the Class G, they are fast acting for low ampacities, and then we do have time delay for larger ampacity units, 7 amp and 60 amps. And we do size reject based on the ampere rating. So by UL standards, we're going to make sure that we do reject, so you can't put in necessarily something too large. The nice thing is for OEMs in particular, this fuse is a low-cost solution. So if we're building anything like rack PDUs or any kind of specialty data center type systems, these are a fairly inexpensive fuse. They're a very good fuse, very good current limitation, very small, and they act very well. But they offer a nice general protection. We're talking about server rack protection, industrial control panels, some lighting circuit protection, and industrial OEMs, certainly love these, but certainly not as popular as a Class CC. That's more of a general purpose fuse that gets used in front of, a lot of different types of circuits. So we move on to the next type of fuse. So Class T, we put in quotation marks tiny. The reason we did that is because for how much current this thing can handle, it's a pretty tiny fuse. So this fuse in particular, once again, not nearly as popular as a Class CC or some of the other fuses that are out there, but certainly they're out in the marketplace. And we see these things a lot of times in front of variable frequency drives. And why is that? Well, one, they're small. The other reason is we have 2 different ratings on here for voltage ratings. There's a 600 volt rating and there's a 300 volt rating. They're part of our Limitron family. They also have a very high interrupting rating. They're 200,000 amp rated device. They're very fast acting. So these things you do not want to put in front of a motor or those applications because of how fast they act. They don't have any kind of overload element in there. So these things, when they do see a short, they're going to act very quickly, and they're going to make sure they take your system offline very quickly if there is a fault, a short circuit fault. So we look at applications for these things. We've got multi-family meter stacks. That's a very popular application. We've got VFD line protection. So if there's any engineers on here or anybody does industrial control, many times you'll see it on a spec for variable frequency drives that they'll say, you know what, we need to use a Class T in front of this drive to make sure that we protect the system. So in many cases, though, just to let you know, when we're putting these in front of drives, if you got IGBTs and drives and they start to fail, these fuses are there to make sure that you don't have a catastrophic failure, right? We want to make sure that we protect the people and components around, but in general, if that VFD decides to fail, our fuse is going to be there to make sure that there's no large impact to the system. So when we look at these as well, we put them in, they can be put in main fusible switches, and once again, we put them in large power drives as well based on the manufacturer of the drive. But very good. When you look inside these things, they're very small. They go all the way up to 1,200 amps for 300 volt rated systems and up to 800 amps when we're talking about 600 volt rated systems. So it's a very good current limiting, very fast acting fuse for the marketplace. When we look at Class K5 and Class H fuses, these are kind of our basic fuses. And these fuses have been around for a long time. I don't know if anybody out there is old enough to remember things used to have renewable fuses. So renewable fuses have been around for a long time as well. We're not going to show those in this presentation, but that was an older type of fuse that you could actually open up and replace the links. So we talk about a K5 or an H. These a lot of times will be described as a one-time fuse. In general, it was confusing even when I came on 13 years ago because basically every fuse out there is a one-time fuse, right? When you see a current, overcurrent, it opens up, we're going to replace that fuse. So in this particular case, it's a non-current limiting fuse. It's a non-time delay fuse, and it's limited by how much fault current it can interrupt. So up to 60 amps, this thing can interrupt 50,000 amps. Above 60 amps, we're at 10,000 amps. So in our part numbering scheme, we have an NON series, which is a 250 volt rated class, and then an NOS series, which is our 600 volt rated class. So this is kind of our base fuse. And when you look at this fuse, as I mentioned in a couple of slides ago, this fuse does not have any kind of rejection feature to it. This is kind of the basic fuse. When you see if there's anybody out there who has any kind of disconnect switches or you're buying a disconnect that says I want Class H or K5 clips in there, I strongly urge you not to use Class H and K5 slips. You really want to move up to Class R clips if you can. So when you do that, you move up to a better class of fuse I'm going to show you in a minute, because what happens is if you put that disconnect switch in and you don't know for sure, and you put in Class H fuses, you may have over 10,000 amps available to you. You may have a little bit more than 50,000 amps. So when we get to a Class R fuse, you'll see in a second, those fuses can handle a lot more fault current and are a lot better for industrial applications for sure. So in this particular case, though, we use a lot of them for HVAC disconnects. We use them for low-cost branch circuit protection. I've used these on certain applications for resistive loads where it's a low-cost, application for sure. And they're really on light-duty circuits where you don't have much fault current and maybe a very cost-conscious customer as well. But certainly, we recommend upgrading to an RK5 or RK1. And once again, it's inexpensive, but it does have a lower level of protection for sure. So as we kind of move to the better class of protection, which is our RK5 series. So the RK5 is kind of our workhorse of a fuse at Bussmann. So we sell a lot of these fuses for industrial applications, for safety switches, motor control centers. We put them in panel boards, switchboards, those types of applications. When we started color coding our fuse a few years ago, we did, even though fuses are very low resistive ratings, we actually found out that this is energy efficient compared to our other product families or other RK5s out there in the marketplace. So we decided to label it as a green product as part of our Fuses Made Simple program. The nice thing is when you talk about RK5, these amp ratings go all the way from a tenth of an amp all the way up to 600 amps. And when we look at the voltage ratings of these, we have a 250 volt class and we have a 600 volt class. The nice thing is you can't screw it up. If you got a 250 volt rated system with 250 volt rated devices, you're only going to be able to put in a 250 volt rated fuse. When you got a 600 volt rated system with 600 volt rated devices, you're going to be able to put a 600 volt rated fuse in. So the nice thing is these are sized based on the voltage as well as the current that you have. We have optional indication on these fuses. This is a true dual element design. So we're going to have, and now we have a device in here that's going to have an overload element and a short circuit element that we talked about earlier. They're going to have a 200,000 amp rating. So most customers out there now, unless you're in a major metropolitan area, 200,000 amps is going to be plenty of fault current, plenty of interrupting rating for your applications. We do see some areas of the United States that has more than that, but it's rare. Most of the time it's going to be less than that. But the nice thing is, with this fuse, you'll be able to handle most of the applications in the States. So why do we choose it? It's the best time delay performance versus an RK1. So when we look at this fuse, we can size this fuse very close to the actual load of the motor or whatever you're going to size it for. So we can size it close to the load, and that reduces the fuse and switch size. The nice thing is also we offer backup overload protection for motors if we size it at 125%. Because of how much time delay we can build into this fuse, we can size it very close to the motor. And what happens then is if for some reason your overload on your motor starter fails, or it doesn't operate for some reason, and you do size this for a backup overload protection, this fuse will open up. It'll see that overload condition and will open up in a timely manner. And the nice thing is it's a lower cost than some other fuse classes that are out there that I'm going to go through shortly. So some of the applications for this are panel boards and switchboards, motor control centers, branch and feeder circuit protection, and electrical distribution and OEM equipment, enclosed combination starters, industrial control panels and machinery, safety switches, and busways. So I strongly encourage you, once again, if you're buying a safety switch, make sure it has the R clips in there. So when you're buying this, you make sure you put an RK5, and that will also accept the next fuse up, the RK1 series fuse. So when we look at RK1 fuses, we make a few different styles of the RK1 as well. So as I talked about earlier, once we meet those minimum criteria for UL, we can kind of tweak it a little bit. So in this particular case, we have our best-in-class low-peak series of fuse. So this product, our LP, LPN, and LPS RK, can certainly take the place of our class RK5 fuse and even our K5 and H fuses. So this fuse is nice because I can upgrade and move to this fuse, and it gives you a very high level of protection. It's still a dual element time delay fuse. We can have optional indication on here as well. And this fuse goes all the way up to 300,000 amps of interrupting capability. So when we look at the fuse below that, the KTN and KTSR, these are a Limitron series of fuses. They have very good protection, but it's a fast-acting fuse, and it's designed really for a lot of heating applications, or maybe something where you don't need that time delay or don't want that time delay. But at that point, we limit it to 200,000 amps of interrupting rating. So we do make two different versions of our RK1 fuse, but I would say in general, most times we want to upgrade to the LPN or LPS RK. When we look at, why do you choose it, certainly better current limitation than an RK5, and it may reduce arc flash hazards. I've been in cases where an RK5 has been in a bus duct, and just by introducing and putting in the RK1 fuse, we greatly reduced the arc flash hazard in that particular case. So you certainly want to look at that with your engineer, but it greatly reduced it. So also we can size this fuse close to the load as well to reduce the fuse and switch size, and it does offer backup overload protection. But because we have a more current limitation in this fuse, we want to size it a little bit higher than the 125% of the RK5. We want to move this up to 130%. So it can be sized very closely as well, but we want to make sure that it's sized a little bit more because of the current limiting nature and how much more quickly this could potentially open up. And then obviously applications are very similar to the RK5. We got panel boards and switchboards, motor control centers, branch and feeder over circuit protection, electrical distribution, safety switches, and busways. So very similar applications than what we had before in the RK5 series. So just to kind of go over advantages once again of a dual element time delay, because I want to make sure I hammer this home that when you're looking at fuses, motor and overload and short circuit protection is very good for motor overload and short circuit protection. We got to make sure that if you have any kind of an inrush to your system, what I don't want, and the calls we certainly don't want to get are, hey, I put a fuse in, it's fast acting in front of the motor and it opened up. Yep, it's going to do that. We want to make sure that we've got good overload and short circuit protection when you put in motor applications for sure. Permits using smaller and less costly switches so we can size it closer to your application. Better short circuit component protection for current limitation. So when we talk about current limitation in the previous slides, when we limit how much fault current gets through, what your peak current that gets through is greatly reduced, and the I squared T is greatly reduced, it's going to actually protect those devices downstream. It's going to protect the motor starters and also the people that are downstream of that a lot better. It also simplifies and improves selective coordination for blackout prevention. We don't have time to go through that today, but certainly in another presentation we could do selective coordination. That will be coming up in weeks to come, and that'll explain what that means. Basically what that means is to limit which overcurrent device opens up based on where the fault is. So if I got a fault, I only want the overcurrent device that's directly in front of it to open up. I don't want it to go upstream and have a cascading event. So we want to limit that and improve how our system operates. And then we have better protection in elevated ambient temperatures. So if you do have a situation that's maybe an elevated ambient temperature, a dual element time delay fuse will certainly work better in those applications. And then finally, we have type 2. It provides type 2 no damage motor starter protection when properly sized. So I don't have a great deal of time to go through that, but the bottom line is when you have a type 1 protection, you can have considerable damage to your contact or overload relay, and it's acceptable. Replacements of components or a completely new starter might be needed, but there's no discharge that's going to happen beyond the enclosure. When we talk about type 2 protection, now we're talking about no damage. So no damage is allowed in the contact with overload relay, and light contact welding is allowed, but must be easily separable. So at the end of this presentation, we'll talk about Selective Protective Devices Handbook that's available through Bussmann. And in there we have a whole section on type 2 protection and how we can use our RK1 fuses to make sure that we're protecting your devices. So we move on to some more fuse classes, and just wanted to show you real quick our fuses made simple. So once again, we color code our fuses now. It's very nice and very easy to watch and to have when you're in the field. So we have our base fuse, which is the NOS series, our better fuse, which is our Limitron, our KTSR, RK1, and then we can kind of go through our green RK5 fuse, and then our best in class, our RK1 low peak series of fuses. The nice thing is that low peak series, that yellow fuse on the left, can replace all those fuses on the right. We can certainly help you out at Bussmann to make sure you're doing it properly, but it will physically fit where all those fuses fit, and it'll give you a very good level of protection, certainly for your system. So moving on to a next class of fuse. This fuse in particular is very strong in the industrial and OEM marketplace. So we're looking at a Class J fuse. It's a much more compact fuse than the RK5 and RK1. Came out later than those devices. Our most popular workhorse for sure is our LPJ series. So this is our dual element time delay fuse. It has optional indication. It's also 300,000 amp rated. So it's in our low peak series family. So it's 300,000 amps. And this fuse size goes all the way from 1 amp up to 600 amps. So it's a very nice fuse. It's been around for a while, and we actually have a new version of that as well called our Cube fuse. So our Cube fuse, which is on this page as well, the TCF and FCF, basically takes the guts of the LPJ. So electrically, it's the same as a Class J. It's just retooled and now put in a finger touch safe system. So the Cube fuse has been around for over 20 years. It's a nice fuse. It's a finger touch safe fuse, very good current limitation, very good ratings overall. It's still a 300,000 amp rated device, and it has the same electrical characteristics as our LPJ series. The JKS series Class J fuse that you see there is kind of our Limitron series, and it's a fast-acting fuse, 200,000 amp rating, typically used in heating circuits or maybe some application where there's absolutely no inrush to your circuit. So once again, a fast-acting device, and we want to make sure that it's sized properly and is sized for a particular application. And typically, it's not going to be used for anything with any kind of inrush. So why choose a Class J? It's the best current limitation and a very good time delay. Smaller footprint versus Class R. You size close to the load to reduce the fuse switch size. Once again, it helps achieve higher SCCRs. So we put this in front of control panels. It's very good current limitation and can actually help raise the ratings of your SCCRs in your panels. So once again, applications, panel board switchboards, motor control centers, branch and feeder protection devices, closed combination starters, safety switches, busway. So this particular fuse, once again, all the way up to 600 amps. It's a nice device, very good, very compact fuse, all 600 volt rated devices, and it's both AC. Just want to make sure I'm clear on that. And if I wasn't clear earlier, one thing I want to make sure, guys, is that when we talk about voltage rating, there are AC and DC ratings for fuses. So we look at The ratings that I talked about, if I say 600 volts, in this particular case, it's an AC rating, but they do have a DC rating on a lot of these fuses as well. So you just want to verify that on the label itself. When we get to kind of the last class of fuse on the UL248, when we talk about branch rated fuses, this is our Class L or large series of fuses. So in this particular case, you know, when we talked about earlier, on a Class L fuse, it's greater than 600 amps. So in this particular case, we actually have a 601 amp fuse. So it's a little odd size, but under UL, we got to be greater than 600. So we go from 601 up to 601 up to 6,000 amps. The voltage rating on these is 600 volts. Some have a DC rating as well. So we're looking at our best in class is our KRPC series. This falls into our low peak family of products as well, our yellow series. And then below that, we actually have our Limitron family. So we do have two other versions. One is our KTU, it's our fast-acting version of our Class L, and one is our KLU, our time delay version of our Class L. So these fuses in particular are large fuses. You know, just like we said, they're up to 6,000 amps. They have good current limitation on high fault currents, and they can coordinate easily with downstream feeder fuses. So when we're talking about the selective coordination that I discussed earlier a little bit, these will coordinate very well with those downstream fuses. Typically, the applications these are in are going to be in large Pringle switches and some safety switches, mainly switchboards, large panel boards, that kind of a thing for sure. It's very rare I put these in their own fuse holders. Typically, what you're going to mount these to is either in a switch or on some kind of busway in your system. So it's very rare that, you know, I'll get a call for fuse holders themselves. So in this particular case, it's usually a system already designed to house these larger fuses. Typically, in you know, some metropolitan areas will get some very large ones, 4,000, 5,000 amp units, but in general, you know, you'll see a lot of 800 and 1,200 amp units of these around in many systems. So now we go away from UL248. We're going to get to supplemental overcurrent protective devices. So what a supplemental overcurrent protective device is, it's a device intended to provide limited overcurrent protection for specific applications and utilize equipment such as luminaires and appliances. The limited protection is in addition to the protection provided in the required branch circuit by the branch circuit overcurrent protective device. So what this is saying is when I have a supplemental overcurrent protective device, it's there to protect a particular thing, not a branch. So in particular, if I look at the small dimension supplemental fuses on the right, I may put those in a luminaire, I might put those in fluorescent lighting. That device is going to open up if that light sees a fault. It's going to protect just that device. In this case, you'll get a little bit of advantage because now it won't take out the whole branch and maybe just opens up that device. And now you know what? The rest of my lights may be on. When we're talking about supplemental protection, the thing to remember is that I can't use a supplemental protection where a branch is required. That's the biggest thing to take away from this. So NEC allows you to use it, but it's there for a limited protection of a particular item. So when we look at our small or supplemental, and we used to call them midget fuses, when we look at these things, they're a small footprint, 13 by 30 seconds by 1.5 inches. There's supplemental short circuit protection. And what we recommend at Bussmann is if you can, we upgrade you to our Class CC fuses. So when you look at these fuses, the concerning point to these is if we go across, so you'll see the one on the left is rated 600 volts, the one next to it is 500 volts, 250 volts. They can be rated to whatever basically we label them to or whatever we've tested them to. So there is a chance that you could misapply these, right? So if all of a sudden we've got a 600 volt application and we put a 250 volt fuse in, it will physically fit. But because it's not a branch rated fuse, it could potentially be put in incorrectly. So that's why we say, you know what, if we can upgrade to a Class CC, when we look at Class CC, they're all 600 volt rated, they're all current limiting, and they're all going to work just fine for the application. So we can certainly help you at Bussmann to do those upgrades and to be able to put you in the proper way, but we just want to make sure that when you're looking at supplemental fuses, they're typically used in control circuits, you know, secondary sides of transformers, and they protect lighting and control circuits. When we look at how Bussmann has migrated over the years, the nice thing is we made this part of our fuses made simple program. So now we've got supplemental fuses as part of that, not just some of our branch. So what that means is we made it a lot easier to read our labels. So when we look at a fuse and it has an orange label on it, we know it's a 500 volt rated fuse. When we look at it and it has a different color, it might be a 600 volt rated, or a teal might be 250. So it's a lot easier to look at that fuse and say, yep, it's a 500 volt time delay fuse, got a 10,000 amp rating to it. It's 500 volts. This is the one that I want. It's going to be a lot easier over time. And our Fuses Made Simple program is nothing new, quite frankly. It's been out for probably 8 years, I'm guessing. So now when you're out in the marketplace and when you're picking up fuses, you'll notice that these fuses have changed over time, maybe from some old inventory of old fuses that you've seen. Another device which I want to make sure that you're aware of and that we sell a lot of at Bussmann are cable limiters. Now, cable limiters are not fuses. They are short circuit protection only, and they're based on the conductor size that you have in your facility or the conductor size that you want to protect. So I want to make sure I put these in the presentation because I'll get calls for these and people ask me about cable limiters, and they're there to protect the cable themselves. So if I have a 500 MCM cable that's copper, there's a specific cable limiter just for that cable. If I've got a 1-aught, there's a specific cable limiter just for that. And they are nice because they're distinguished basically because of their short circuit current capabilities. They have a high level of current limitation. They're available with a bunch of different connections to them. We have tube to tube, we have tube to offset, we have compression rods. So there's a lot of different ways to configure these and to mount these. They're required by many utilities. They're also required in some PV and wind systems if you have lengths longer than 10 feet, and they protect the cables from damage and increase system reliability. You know, many times we'll have these. If you look at the picture on the bottom right, what you see is that might be the secondary of a transformer, and now we've got multiple taps per phase. So now I might have 4 or 8 conductors coming off of a single phase. Well, if any one of those conductors fails, I want to make sure that I just take that one conductor offline and I've got the other 7 available. So a cable limiter will do that. It will also limit any catastrophic failures, because what you don't want is a situation where I have one cable that has failed and now it heats up, and eventually catches on fire and maybe causes a problem in your facility. So what we do is you can put cable limiters in here, and then when you have multiple conductors, you want to put them at both ends of the conductor runs if you have 3 or more conductors. So the nice thing is when this thing opens up, it's going to take out just that one cable. It's going to protect that system. It's going to open up the circuit, not the entire circuit, just that cable, and now you still have continuity flowing through the other 7 conductors that might be going to your facility. So it's a way to protect your system and increase reliability in your system by having cable limiters. And certainly contact anyone at Bussmann, and we'll be able to help you size these and pick these out for you. So once again, if we kind of go back, current limitation versus degree of time delay. So a lot of times, the more current limitation you have, the less time delay you have in your system. So we're talking about RK5. That's the best time delay. It has good current limitation, but not the best current limitation. As we get less time delay, we've got better current limitation. So just know that there is a little bit of a trade-off in your system depending on how much time delay you need versus how much current limitation that you really like to have. And we can certainly help you size those applications up as well. So once again, for new equipment installations, you specify and install the most current limiting fuse. Use class J and CF where possible because they are smaller, they're better current limiting, and they do a very nice job with time delay as well. We do not recommend class H. We want to upgrade you to an RK5. It's a better class of fuse. It operates much more quickly and protects much better as well. And we're talking about arc flash protection as well as component protection. We want to size fuses close to the load to reduce cost and improve protection. So existing equipment, replace non-current limiting fuses with current limiting fuses and upgrade to low peak fuses when possible. So we have programs out there that we can help you with. One of them is our low peak upgrade, and this will help you simplify your inventory as well as give you the best in class fuse as well. So what we can do and what we can offer is we have a low peak upgrade program that is available through Bussmann. So when I look at this class CC fuse that's in this picture, we can take all those existing fuses that are in there and we can upgrade them to one style of fuse. Many times I'll go through an inventory at an industrial account and they'll have ATDRs, they'll have BAFs, they'll have CCMRs, they'll have ATKRs, and we can replace all those with one style of fuse or LPCC. Same thing when we're talking about the class Rs. They may have an NON, a KTNR, an LLN series, and we can replace all those with one series or LPN RK series. So it's a great way to consolidate fuse inventory. It's also very good it's a best-in-class fuse, to make sure that it's going to be very good current limitation, make sure that it helps and protects your system the best, and also reduces the amount of inventory you have to have. So now you got to carry less inventory. You're going to have a best-in-class fuse, and you're going to make sure you have a fuse on your shelf that's going to work, and it's going to work very well. So please contact anyone at Bussmann if you have a hodgepodge of fuses you'd love to upgrade. We'd love to talk to you about doing a low-peak upgrade and help you simplify your inventory. So we look at fuse blocks and holders. I'm going to kind of go through these in the next 10 minutes and all the accessories. But when we look at all these, there's a slew of devices out there in the marketplace to be able to support the fuses that we offer. So when we look at these kind of line by line, I'm going to kind of go through the next couple. When we look at fuse blocks, everything now that Bussmann is doing, we're trying to make finger touch safe. So even when you look at our open style blocks, we have the ability in most cases to make them finger touch safe, and it's a true IP20 finger touch safe. So when we look at our low voltage fuses, class CC, we've got great fuse holders. This one in particular is an open type holder on the top left, but we do have the ability to put a finger touch safe cover on all of our fuses now on the class CC. So we talk about class J fuses as well. We can go all the way up to 600 amps now, which is highly unusual, and have a finger touch safe system. So we got built-in patented lockout tagout features on these as well when you put the cover on. We have modular design to make sure that if I want to make a 1, 2, or 3 pole unit, I can just snap them together and they dovetail together to make a multi-pole unit. So it's a very good system of fuse blocks that we have out there for you. So once again, some of the features that I talked about in this particular case, we have a finger touch safe open type holder where we have an open holder and then we snap on the cover. So in this particular case on the left, it's a hinge cover, so it hinges open and you can get to the fuse and pull it out once you shut the power off. And then we also have label provisions on here. They're IP20. I talked about the dovetail design on these things. They're all DIN rail mountable. And then we have a standard fuse clip reinforcing spring. So the nice thing is we're going to make sure when you put a fuse in, you want it to be a nice tight connection in your system. If you've got a fuse and it goes in too easy or it was very loose, you certainly want to protect your system. You want to inspect your system to make sure it's operating properly and make sure it's a nice tight fit when you go to put that fuse in. It should not be loose. Okay. So other features, when we talked about 70 amps or 600 amps, it's highly unusual once again to have finger touch safe systems. So when we look at these fuses, we got standard fuse clip reinforcing spring. We got phase barriers. We have up to 4 mounting holes per pole. Dovetail design once again, so we can snap these together and make multiple poles out of these, and it's an IP20 finger touch safe cover. So a product that you may not be aware of, and I want to make sure you are aware of it, is our power distribution fuse blocks. So what is it? It's a 600 volt fuse block with a power distribution capability built into it. So we have class J applications up to 400 amps, and we have class H and R applications up to 60 amps. It's a nice device. So what this basically does is it takes the load side of your fuse holder, and we give you the option to have a power distribution on the secondary of this. So in this particular case on the screen, we've got 1 in, 4 out, and it's a nice application. The reason we introduced this is we said, you know what, there's a better solution than maybe having just a fuse block and a power distribution block. So now we created this probably 6 years ago, I believe, in 2015. So now it's all in one, and it's a power distribution fuse block. So it's a very easy, compact way to enhance your system. So, sorry, for some reason the screen hung up. And just to let you know, on the next enclosed rotary disconnects, when we're talking about enclosed rotary disconnects, 99% of the time they're going to either incorporate a class CC fuse or a class J fuse. So just be aware when you're looking at disconnects, just to be so you know what you're getting and what you're installing. If it's a fuse rotary disconnect, it's going to be either class CC or a class J. So just be aware of that. I like to point that out so that when you have your applications, what's available and what you should be putting in. Another device that's available from Bussmann that's very small and compact is our compact circuit protector. So this device has also been around for probably 12 years, I believe, somewhere around there. So instead of having just a standard fuse holder, this device, and in particular the class CC that you see on the left, is the same width as a class CC fuse holder, but it is actually a true UL98 disconnect switch. So this little device is a little toggle disconnect, It can mount inside your panel, can isolate your control transformer. It can actually turn motors on and off from using a disconnect switch, so it's a nice device. So this has been around, like I said, for at least 12 years, and we migrated that product on the left to the product in the middle, which is our class CF fuse holder and disconnect. And the nice thing is that this fuse, once again, these are both available 1, 2, and 3 pole. We've actually taken this product and we've migrated it to the point now that we have a through-the-door disconnect and a rotary disconnect handle. So it's a very nice compact device. The other item that we use this with, if there's any contractors or consulting engineers out there, we actually use this device in the middle with the cube fuse mounted in it as in our panel boards. So it's a very, very typical device you would see in our fusible panel boards, and it's been on the marketplace, like I said, for at least 12 years. So nothing new to the market, but you may have not seen it before. All these are 200,000 amp rated. They're available 1 to 3 pole. They're UL 98 listed, DIN rail mount. It's a very nice compact device. And these go up to 200 amps at this point now with our cube fuse. So as you can see on these, we have finger touch safe systems with our cube fuse. The reason we introduced it 20 years ago. We got blown fuse indication on there. We've got a fuse rejection. We got multiple fuse options on here. We have a compact size. Many of these are 40% smaller than a traditional fuse. In our switch itself, there's a lockout tagout feature. There's a fuse indication. Finger safe. Even when you pull the fuse out, it's a finger safe condition. We have a switch interlock so that when you have the switch in the on position, you cannot pull the fuse out. Once you turn it off, you can then pull the fuse out. And we also have a rejection feature built into here as well to make sure you're not going to put in the wrong size fuse. And then also you can put in the time delay cube fuse as well as the fast acting cube fuse into this application. So one of my last slides, I just want to make sure that you're aware, we have a lot of resources at Bussmann. We have a fault current calculator that's available to you. I encourage you to go on the Bussmann website. We have a fuseology handbook. So it is available through download, or if you can get a copy from your local salesperson, Bussmann salesperson, we can get you this as well. And probably our most technical resources are selecting to protect the devices handbook. So this has been around for a long time. I got my first one in 1987. So it's been updated every 3 years based on the National Electric Code. So it has the benefits of modern current limiting fuses. It talks about electrical safety. It has power systems analysis. It has maintenance devices in there and how you properly maintain your devices, equipment application and protection. And finally, we have a Bussmann series full line catalog. So you could talk to your local Bussmann rep. We can certainly get you a catalog in your hands. But we strongly encourage any other questions that come to us. We'll be happy to answer them for you. And one other thing, I strongly encourage you to continue on with the Bussmann University, because there's a lot more good information to come. And that's about it from my presentation. If there's any questions, certainly put them through the chat window, and we'll be happy to help you. Thank you very much for attending.
Matt. Thank you so much, Matt. 1987. Wow, that's when you got your first SPD.
I was 4 years old.
Oh, yeah, sure. Well, thank you all so much. This concludes today's webcast. On behalf of the Bussmann Series team, thank you so much for your time today. Have a wonderful rest of your day. Take care.